All right, so we are finishing up with lesson 5.7. This will be the last lesson of 9th grade math. That's pretty exciting. In this lesson, we talked about an investigation that basically the whole point of it was how can we solve a problem and then apply that theory to developing our proofs. So as we saw, the goal was to get from 1 all the way to 100, but in order to do so, I could only do the operations with 2 or with 5. But notice that if I want to go from part 1, I have so many choices. I can multiply by 5 to get to 5, multiply by 2 to get to 2, or add 2 to get to 3. So that gives me 3 possibilities of where to go. Whoop. All of a sudden we have lots of things for sale. Let's ignore that for a second. Oh, there we go, went away. But if I go to the end, and I think, okay, what can I multiply or add or subtract or divide by 2 or 5 in order to get to 100, I only have one option. I can add 5 to 95 to get to 100. But I can't do anything else to the other 2 numbers in order to get to 100. So that gives me one option. And then working backwards from there, where I would multiply by 5, add 5, multiply or divide by 2 in this case, but working backwards, I'd multiply by 2, add 2, multiply by 5, add 2, add 5. That's the route I would have had to take in order to get back to 1. So then going the other direction, I could write out those steps. So working backwards is easier sometimes than working forwards. Begin with the end in mind, and you develop your proof that way. You want to prove something, well, what do you need in order to prove that, and how can you find it? Another thing we talked about, if you read the part of the textbook that I told you to, is if you have a concave kite, that's called a dart. Remember that a kite means that consecutive sides are congruent to each other. Well, if that's concave instead of convex, then that's called a dart. You sometimes see that picture in your shapes and whatnot. Okay? So a couple of pieces of information that you needed to know. And really the whole point was, how can you use that to better develop your proofs? This proof asks us to prove the conjecture. The diagonals of a rectangle are congruent. So we know this conjecture was given to us in lesson 5.6, and now we want to prove it. So we're given rectangle YOGI, with diagonals YG and OI. These really should have symbols above them. And we want to prove that YG is congruent to OI. So let's take a look at how we could do that. Now, one example is to use a flowchart proof. We haven't had a formal lesson on flowchart proofs, but you've seen them all, and I think a lot of you have developed some really good techniques with it. So let's take a look at how you could do one for this example. So step 1, really step 1, 2, and 3 are all interchangeable. That's the whole point of the flowchart, is it really doesn't matter which one you start with. But let's say that IY is congruent to GO. Alright? And IY is congruent to GO because opposite sides of a parallelogram or a rectangle, since a rectangle is a parallelogram, are congruent. Of a rectangle are congruent. I'm using shorthand here because, again, makes things go a little bit faster. And we can have angle YOG is congruent to angle OYI. So YOG is congruent to angle OYI because of the definition of a rectangle is that all angles are congruent to each other. It's a parallelogram with 4 congruent angles, so that's what a rectangle is. And we were told that this is a rectangle. And then we have YO is congruent to OY because it's the same side. So a common side. And all of that can lead us to the middle. We've talked about sides, we've talked about angles, we've talked about sides. I'm guessing we're going to prove that triangle YOG is congruent to triangle OYI because of side angle, side conjecture. So let's take a look at what that triangle is. We have YOG, and we have angle OYI. So notice now we have corresponding sides. So this is leading down to our final step, where YG is congruent to OI, and that's because of corresponding sides of congruent triangles are congruent. So a very simple 5-step, 5-box situation in order to prove the conjecture is true. So using proofs, whether it could be a paragraph proof, you write all this out in sentences, or a 2-column proof, or a flowchart proof, as long as you can give logic and order to your thoughts and use deductive reasoning to prove your statements, you can back up your problems. And really, that's what geometry is all about. Can you use reasoning, whether inductive through investigation or deductive through using conjectures? Can you prove something to be true? Not saying it just because, oh, it looks like it's true or not. All right, and as usual, if you have any questions about this lesson or anything from chapter 5, please make sure you come and see me. Good luck on your test.